Good evening, student. Today is going on online physics class. I am Pratyush Kumar Acharya. I will discuss about electric field intensity due to an electric dipole along the axial line. Before I start about this one, I have already discussed about dipole moment, ideal dipole, etc. But something are revised to you, like as dipole. What mean by dipole? Two equal and opposite charges are separated by a small distance apart. That is called dipole. Now I have to consider or assume that two equal and opposite charges, this one is the positive charges and this one is the negative charges, both are separated by small distance apart and the distance between them is 12. The two charges are situated both the points A and B respectively. Okay, and O is the center of the dipole. The distance between OA is L and distance between OB is also L. Okay, according to question, electric field intensity due to an electric dipole along the axial line. So this is the axial line and this is the vertical line. So now we have to calculate electric field intensity due to axial line. Okay, so here we write, so this is the point P. This is the point P. Okay, at that point P, we have to calculate electric field intensity due to plus Q charge and also due to minus Q charge. So that system of charge represent as a dipole. Let us assume a test charge, that is plus Q naught charge, which is placed at point P. Now that point P, which is at a distance r from the center of the dipole. Okay. Therefore, we have to calculate electric field intensity at that point due to an electric dipole. Here we write, let us consider an electric dipole having two equal and opposite charges plus Q and minus Q, and they are situated at points A and B respectively. Distance comma distance between them is 12. Distance between them is 12. Okay, let's a point P along the axial line of the dipole, which is situated at a distance r from the center of dipole. O. That is OP equal to R. Now we have assume a test charge. Now we have assume a test charge Q naught, that is plus Q naught, at point P, so that we have calculate electric field intensity at point P due to dipole. That is the all about theory of electric field intensity due to dipole. Then derivation. The force experienced by test charge plus Q naught due to plus Q charge is given by कौन होगा देखो. So here test charge here due to plus Q charge, the force experienced by the test charge, that force is repulsive force because source charge is positive. So positive charge is here and that is the negative charge. Negative charge. Okay, due to source charge, the test charge create a force of repulsion. That's why the force which is moves away from, directed away from the source charge. Okay, and that's why the electric field intensity is also moves away from it. That is E1 vector. Here write the force experienced by the test charge Q naught due to plus Q charge is given by F vector whose magnitude equal to, according to Coulomb's law, 4 pi epsilon 0, 1 by 4 pi epsilon 0. Q is the source charge and Q naught is the test charge. Both are similar in nature, divided by R square. R square means distance between A, P is given by, so total distance between OP is R and distance between OA is L. So we have to subtract that one. So it can be represented as AP is R minus L. Okay, so the distance between AP is R minus L. So here R square means AP square. So here we write AP square. Okay, we know that is F1. We know electric field intensity 1 equal to force experienced by a test charge, that is F1 vector by Q naught. So here we write E1 vector, that implies rho mod equal to 1 by 4 pi epsilon naught Q naught by AP square, means R minus L rho whole square, divided by Q naught. So Q naught cancel out. That implies E1 vector rho mod equal to 1 by 4 pi epsilon 0 Q by R minus L rho whole square. Along what जाउछि, along the direction OP vector. Along the direction of OP vector. Similarly, force experience by test charge q naught due to minus q charge, that can be represented as f vector equal to, that means f2 vector rho mod equal to 1 by 4 pi epsilon naught q naught, that means their magnitudes, so it is minus magnitude is q, so q naught by bp square. Okay, so here, right, so this is the b and this is the point p. Due to minus q charge, this is the minus q charge and this one is the plus q charge. Due to minus q charge, the force experienced by the test charge, that force is attractive force and that moving along the direction of PO, like that, along the direction of PO, and that can be represented as, so electric field intensity is moving along the direction of force, so it can be represented as E2 vector. Okay, clear? Then, and the distance between P to B, P to B, OP is R and OB is L. So what is the distance between BP? That is called R plus L. So total distance between B to P is R plus L. Okay, clear? So here we write, so F2 E2 vector mod equal to F2 vector rho mod by Q naught. That means 1 by 4 pi epsilon naught Q naught by Bp square divided by Q naught. Q naught cancel out. So here we write 1 by 4 pi epsilon naught Q by Bp square, which is equal to 1 by 4 pi epsilon naught Q by R plus L rho whole square. So the direction of electric field intensity along the direction of PO vector, direction of PO vector means electric field intensity whose direction along the direction of PO vector. Clear? Along the direction of PO vector is U1 and direction of PO vector is E2. Clear? So this is the equation number 2 and this is the equation number 1. Now, therefore, net electric field intensity due to an electric dipole is given by what? It means E net, whose magnitude equal to E1 vector mod minus E2 vector mod. Why it is subtract from E1 to E1 to E2? Means E1 vector minus E2 vector. That means here E1 vector whose intensity is more because the point P is very closer to point A, but E2 vector is less strength as compared to E1 because the point P, which is more distance from the sources, minus Q. Okay, therefore we subtract from E1 to E2. That's why net electric field intensity E net equal E1 vector minus E2 vector. So E1 vector can represent as 1 by 4 pi epsilon 0 Q by r minus L rho whole square minus 1 by 4 pi epsilon 0 q divided by r plus L rho whole square. Clear? Now taking common 1 by 4 pi epsilon 0, here you write, that means q divided by 1 by 4 pi epsilon 0 taking common, that means here you write 1 by r minus L rho whole square minus 1 by r plus L rho whole square. That implies q by 4 pi epsilon naught into, you're taking LCM. So what will happen? That means r minus L rho whole square into r plus L rho whole square in denominator, but in numerator it can be represented as r plus L rho whole square minus r minus L rho whole square. If you represent r plus L square equal to a square and r minus L square equal to b square, so a square minus b square means a minus b into a plus b, or a plus b into a minus b. Here we write. Okay, clear? So you will write 1 by 4 pi epsilon naught into q, that means q by 4 pi epsilon naught into, you're taking LCM. So here in denominator r minus L r square minus L square rho whole square, that is the product of r minus L rho whole square into r plus L rho whole square, that is the r square minus L square rho whole square after calculating. Again here we write a plus b, that means r plus L plus r minus L, that is a means r plus L, b means r minus L, into r plus L minus of r minus L. Here we write, that means a plus b, a minus b, a square minus b square formula. So that means q minus q by 4 pi epsilon naught, if you cancel out, that is LL, and here also that is 2r into r plus L minus r plus L. Here you write, that means r square minus L square whole square, q by 4 pi epsilon naught into 2r, here LL cancel out, sorry RR cancel out, here you write 12 divided by r square minus L square whole square. So your net electric field equal to q by 4 pi epsilon 0 q 12, that is 2lq means p, that is the electric dipole moment. So it is represented as 2r into 12, here same thing is represent r square minus L square whole square. It is also represented as 1 by 4 pi epsilon naught q12, that means p, and 2r divided by r square minus L square whole square. Here E net field equal to 1 by 4 pi epsilon 0 2 p r by r square minus L square whole square. So this is the net electric field intensity at point P due to an electric dipole. Now if length of the dipole is very small as compared to r. R means distance between the center of dipole and the point P, where we have to calculate electric field intensity, that is OP is distance r. Then square of the length of dipole, that means L square, which is much less than that of r square. যদি L ছোট हुए r ଠାରୁ তাহলে তার পাওয়ার কোন হবে বহুত ছোট হইଯିବ L square r square ଠାରୁ, L square which is less than that, much less than that of r square. Therefore L square can be neglected. Okay, so electric field intensity net equal to 1 by 4 pi epsilon naught. It means 2 pi r by r square minus L square by O whole square. So L square taken as tends to 0. So L square tends to 0. So E net field more equal to 1 by 4 pi epsilon naught 2 pi r by r fourth. Here even I write it equal to 1 by 4 pi epsilon naught 2p by rq. So this is the magnitude of electric field intensity at point P. Whenever the dipole whose length is very small to r. Now I have to calculate magnitude. Now I have to calculate direction. Sorry. In vector form, E net vector equal to 1 by 4 pi epsilon naught to P vector by RQ. Here, 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 the direction of electric field intensity acting along the direction of dipole moment. Okay, only in only along axial line. Only along axial line. That means the direction of electric field intensity acting along direction of dipole moment. Only for in along axial line. That means here in that case, so we know the direction of dipole moment always moves from negative to positive. Similarly, the direction of electric field intensity, that is more amount of intensity along OP direction as compared to PO direction. That's why net electric field intensity moves along OP direction, which is acting along the dipole moments. Clear? So, so that is the direction as well as magnitude of electric field intensity due to an electric dipole along axial line. Clear? Thank you.